So, in our today's class, we are going to study vertical circular motion outside a circular track. So, yesterday we have studied that vertical circular motion inside a circular track. So, if I have taken, for example, like inside a circular track, if an object is moving, like we can take a bob, pendulum bob. Yesterday, do you remember everybody in the class, all of you? So, if I take a bob, so to rotate it, make it a complete rotation. If I have taken so that I need to give a certain velocity. So when the bob is hanging here, if it is traveling with a velocity v naught at the minimum bottom B point, let me take this is A point and this is the B point. So if I give the velocity v naught, if it is very, very low, what will happen, guys? It will make the periodic motion. It will go to maximum height, certain height, and again it will come back to the certain same height and it will do the oscillation. Now, if I keep on little bit increases, that velocity will reach us to the horizontal position. Horizontal position means what is the angle, guys? 90 degrees. From that point, the force is not sufficient to reach the maximum point. That is what top point. So it once after crossing the first coordinate, so the what will happen, guys? At a particular place, tension will become zero. That is what n normal reaction becomes zero. So at that point, the body will start taking into what path? Everybody. It will be falling into the, yes, please. It will falling into the what? Projected. So that, so we have calculated yesterday, what is the minimum velocity at the A point? That is what at the bottom and the top point. So what is the minimum velocity at the top point, everybody, to make the body to move? We have calculated yesterday. How much it is? Root over GL. And at the bottom, what is the minimum velocity required to make the body to make complete rotation? Complete rotation. If you want to revolve the complete rotation, so what is that velocity? Minimum velocity we have to give at everybody. Root over 5G. So that is what we have derived in the yesterday's class. And we have been proved that where the tension is maximum, at the bottom or at the top. Everybody? When the bob is reaches to the maximum point at the top, so tension will become minimum, almost is equal to 0. So that is what we have been proved, that tension is equals to mv square divided by r minus mg. Because why at the top tension is minimum, everybody? Because at that place tension is always acting downward direction, and here mg is also, weight of the body is also acting downward direction. So what will happen? mg plus t, which is equals to force, centripetal force along the radius. So tension is equals to mv square by r minus mg. But if you take the bottom, what is happening? Tension is acting towards to the center, and weight of the object is acting what direction, everybody? Downward direction. So that tension is equals to, so we all knows that mg plus the force which is exerting outside direction, that is what centrifugal force, that is what mv square by r. So that is why at the bottom tension is maximum and at the top tension is what, everybody? Tension is minimum. So that is what we studied in the yesterday's class. Am I right or wrong? Everybody clear? Mr. Rudresha, all of you? So this is motion inside. All of you remember that? This is motion inside the circular track. So like if you take a roller coaster and all, so roller coaster and all, you can take it. It is momentum inside the circular track. So inside the circular track, this is what we'll say. For example, roller coaster, you can see the path will be like this. Am I right, everybody? Pradosh? So what will happen? The vehicle will come and it will take U-turn and it will start moving into the another direction. So like this roller coaster, the vehicle, the body will travel inside the circular track. Am I right or wrong, everybody? Yes or no? So there will be a velocity to make the body to move. That is what it is, root over 5GL to make complete rotation. Now, you all goes any kind of like celebrations, temple celebrations and all. So we all people knows that there will be a circular wheel and people are sitting in the buckets. Do you remember, everybody? Like small bucket, people used to hang it. Yes or no? All of you? Please respond.
Yes, sir.
So in these cases, you can see, so always, all of you, The objects are present outside. So they are not falling, but they are revolving around the particular path. Or else you can take sun. So sun, if you imagine the path of a earth which is taking revolving around the sun, if you consider, actually it is not a circular track, but it is a circular track. If you consider let is the circular track, so around the sun, so earth is continuously revolving outside or inside, everybody. Yes or no? Outside. So like that motion, how the earth is revolving around the sun. So that is what vertical circular motion. Yesterday we studied inside the circular, vertical circular motion inside a track. Now, today's class we are going to see vertical circular motion where we are going to study outside the track. Do you understand, everybody? So mainly for satellites and all. So satellites and all, they are revolving around the earth, around the moon, around the sun, around the other particles. Am I right or wrong? Everybody clear what I'm saying? All of you? So now, that is why, so what is the velocity which we have to make it the body to revolve in a particular orbit? That is what we used to call as orbital velocity. What we used to call, everybody? All of you? Orbital velocity. So let us discuss generally. So later I will show you the picture also. I want to find it in the book. Okay. So there is a book actually. Yesterday morning, today morning I have sent you one book. Have you all checked it, everybody? Such a beautiful book it is. Yeah. So that is one of the nice book. So whenever time permits, please go through that. So it will definitely will help you to better understanding the mainly force and laws of motion. Again, individual PDF also I have sent you. Just have a glance. Such a beautiful questions you can find it in that. So imagine that, for example. So generally I'm discussing, let me imagine this is the earth now. So I want to make one satellite to revolve around the earth. Now Mr. Rudreswar is standing here. Now imagine he has been thrown with some velocity. So this velocity is some, let me take V1. So this satellite is keep on traveling. At certain point, it has been falling into free fall. That is what we used to call as some motion. What is that called as, everybody? Projectile motion. When projectile motion body at a particular distance, after traveling particular distance, understanding. So in a particular angle, normal reaction will become how much? Everybody, normal reaction become 0. So that at that point, body will enter into the projectile motion. Now again, he has been make it into some other velocity. So in this case, body travels certain distance more, and then it will be falling into the what motion? Everybody, it will falling into the projectile motion. So now in this case, so we have to give a certain velocity. So that body will never turns into projectile motion. Instead of projectile motion, what will happen, guys? Always the body will revolve around the particular body. So that is what we used to call as orbital velocity. What we used to call, everybody? We used to call as orbital velocity. So without this orbital velocity, we cannot launch any kind of satellite around the Mars, around the Earth, around the moon. Recently, we launched one satellite. What is the satellite launched by ISRO, Indian Space? Chandrayaan 3. So that orbital velocities, you enter recently 2 days before it is entering into the moon's orbit. Now, just now after 9 days of launching, it is left from the Earth orbit and it has been entering into the moon's orbit, lunar orbits. Am I right or wrong, everybody? Yes?
Yes, sir.
Yes.
What velocity they will launch it? Everything has been monitored. So that is only we used to call as VCM outside a circular track. What do you mean by VCM, everybody? Vertical circular motion. Yesterday inside, now today what? Outside a circular track. Okay, please make it. So VCM, vertical circular motion outside a circular track. So most important one. So concept, if you understand, sums are very, very easy here. So try to make attention. Small doubt, if you are having any small doubt also, immediately just ask me. Okay, everybody. So now, imagine all of you. So I will try to draw with the things. Let me consider this is only semicircle I have taken. So from the semicircle, we all knows that. I will draw the lines first. So what is that? Any direction if I go, something is remains constant. What is that, guys? Yes, yes. From the center. Pradosh?
Centripetal.
Yeah, you can take it center. No, radius. What is that?
Radius.
Radius is remains constant.
Radius.
So let me make it into a dotted lines so that you will all understand. So very easily. So this is one. So I will take it into another one also. So see, for your purpose only, I am drawing the diagram more better way. So try to make it. So this is what is from the center. So let me make this is the center now. So both are same. What is that called as? Everybody. R. Am I right or wrong? Let me take this is the center of the path. Okay. Now this will become what? Totally. This total length will become what? All of you. Respond. Total length is equals to how much, guys? R. Understanding? And this total length is equals to also how much? Speak.
R.
R only. Ready. Okay. Imagine exactly body is at here, exactly at the middle. Now two cases I will teach. Both cases you imagine. So what is the mass of the body? Everybody? Mass of the body is?
M.
Yes, please. Mass of the body is at M. And let me take this point is A. I'll take with the different pens. Please, you also mark it. So what is this point, everybody? This point is what? Everyone. Point A. Okay. Now let consider, let already body is having some initial velocity U. What is the initial velocity? Initial velocity is not equals to 0. So already body is having initial velocity is how much, guys? Everyone respond. Already body is having initial velocity is how much? U. Okay, everyone. So at every point, initial velocity act what direction? Perpendicular direction. This is what we all people knows. Am I right or wrong? Speak loudly.
Yes,
Everybody clear? All of you? So imagine,
yes, sir.
all of you observe. I'll try to draw and explain you. So imagine the velocity. I don't know what is that velocity. So that velocity of the body is U, initial velocity. So that body started sliding. Body started sliding. After reaches to particular point, let me take that point is B. What is that point, everybody? What is that point, everyone?
B.
Point. So by the time from the center, it will make some angle. Am I right or wrong? Everybody clear? Yes, please.
Yes, sir.
All of you. Let me take that angle is
Yes, sir.
theta. What is that angle, everyone? That angle is theta.
Theta.
So at a particular point where n becomes 0, normal becomes 0, means in the sense of at that point it will lose the contact. It will lose the contact between the surfaces so that it will enter into the what? Lose the contact so that it will turns into the what? It will turns into the what? Instead of sliding, it will form into the what, guys? Projectile motion. Understanding? So at a particular point, I don't know what is that point. It maybe happens to here or maybe here or here or here based upon the initial velocity because I don't know initial velocity. Do you understand what I'm saying? Mr. Narayan, Pradosh, understanding? So I have given a certain velocity. I have given a certain velocity, initial velocity U. After coming to this point, maybe body fall into the projectile motion. Or after coming to this point, maybe fall into the projectile motion. After coming to this point, it may be fall into the projectile motion. Means based upon the initial velocity, after sliding on the surface at a particular point, see, now here normal is maximum. Here is normal is maximum. When the bodies keep on sliding, you remember, normal forces keep on decreases or increases. Everyone. Normal reaction will keep on, everyone, decreases. So at a particular point, any point, maybe normal reaction becomes 0. Wherever normal reaction becomes 0, at that point, body will start falling into the what? It will follow the new path, only called as projectile motion. Understand? Rudreswa? So at a particular point, let me take. So at the B point also, body is having some velocity. Am I right or wrong? Will you all agree with me? Yes or no?
Yes, sir.
Respond. Yes. So now let us apply work energy theorem. So no external force is applied. So what is the work energy theorem we'll apply, guys? First equation or second equation?
Second.
Work energy theorem. All of you should respond. Work energy theorem. THEOREM. So work energy theorem. What is that? In a final kinetic energy plus final potential energy, which is equals to initial kinetic energy plus initial potential energy. So this is only we can call final mechanical energy is equals to initial mechanical energy. Is it okay, guys? All of you?
Yes, sir.
Yes. So that is what it is. Now, all of you observe very carefully. Final, let me take. So final kinetic energy. Body is having a velocity at this point. What is the final kinetic energy? Everybody. Body is having at a particular point, V. So what is the final kinetic energy? Half M V square plus now. Initially, observe very carefully. This is what we used to consider as a baseline. So at the baseline, if I consider this is the baseline, what is the initial potential energy? This is the baseline. So what is the initial potential energy?
Zero, sir.
Yes. So U,
Zero.
not initial velocity, initial potential energy. So initial potential energy is equals to 0. It is a baseline. All of you understanding? Clear, everybody? Please respond. All of you. So that is what, let me take it is 0. Now, final potential energy, tell me. So body traveled a certain distance. This is the distance body traveled. All of you check it. And it is came to this point. Now this is what is above from the center. So now I want to find this is the distance traveled by the body. So can you tell me what is the distance height? How much height it is? So how I need to find this height? Now I will teach you, all of you observe very carefully. So this is the height body came down, because we all know that potential energy is independent of what? 9th class also you studied, and now 11th also. Potential energy is independent of what? Independent of what? Independent of path. Only initial point and final point is considered. So initially body is at here. Now finally body is reaches to here. So as it is a baseline, we will consider initial potential energy is 0. Now body is at here at this point. So this is the change in height. So now how to find that height? All of you observe very carefully. Now at this point, all of you observe very carefully. At this point, weight of the body is acting what direction? Weight of the body is acting what direction? Speak, guys. Downward direction. Means force will split into two different directions. What is the two different directions? So here is the theta, means then here also theta same. So here what will happen? This will become what?
Cos theta.
Cos theta. And opposite one, this will become what? Mg.
Sin theta.
You all should speak, so that mg will disappear. So now all of you observe, and there is a force which is exerting opposite direction. What is that force we used to call as? All of you. Yes, perpendicular. Normal. Because weight is downwards, normal is upward direction. So now all of you observe how to find this height. Check it, everybody. I will redraw. So this is what the initial baseline of the body. Now the body has traveled this much height, and it has been came to this point now. So now all of you observe, we all knows that this is called as R. Am I right or wrong, guys? All of you clear? Everybody? Radius only. Correct or not? Yes, please respond. And this total height is also, which is equals to R only. Now this is what is the height, the potential energy, we have to find it. So we all knows the potential energy formula is what? Final potential energy, mg h. So h is equals to how much? That is what the question mark. So how to find the h? All of you observe. Here, as the weight of the body is acting downward direction, so force will split into two different directions. This is what? Mg sin theta. And here what will happen? This will become, everybody, mg. Respond, mg cos theta. Clear?
Cos theta.
Now, if this total is R, means all of you check it now. So as we all knows that this is actually the total height. This both are perpendicular. So this is also will become R. Actually R it is. So it's not mg, R. So this will become what? All of you should respond. R mg cos theta. Yes or no, guys? So this total is R, and this height what will become? This is mg cos theta, and here what will happen? This will become R. You should speak. Sides, this is a triangle. All of you check it. So now we all know that hypotenuse is, this is mg cos theta. This is what it will be become. So mg cos theta means that force is radius R it is. So this is R cos theta. So now this height will become R cos theta, and this total height is will become what? R. Now what is the remaining height? Anybody can tell? Remaining height will become what? Everybody. R minus R cos theta. R minus R cos theta. All of you observe. Once again, I will say you. So imagine there is a particular case. So this is the initial point, and the finally body has been reaches to here. There is the thing. So this total one, we all knows that. What is the total height from the initial point? This is the radius. Am I right or wrong? Everybody clear? Please respond. And this point is also we used to call as what? Radius only. So now this is the change in height. This is the change in height, the body. So this is what h we have to find it. So let us observe, if the angle is theta, Now we all knows that here what will happen at a particular place, n will become 0. So body will takes into what motion? Everybody. Body will takes into what motion? It will takes into projectile motion.
Projectile motion.
If it is h, all of you remember, if you want to calculate this h, so which is equals to, so as we all knows that in this component, weight of the body is acting downward direction. So this will become r cos theta, and opposite, this one will become r sin theta, resultant force. So now all of you check it. So if this is here, see all of you, this is what it looks like. This is what r. So now here what will become this one? This will become r cos theta, and this will become what? R resultant force. R sin theta. So this is r cos theta. So this height, the height which is present here, we got it as r cos theta, and the total height which is equals to what, everybody? R. So height h is equals to what will become? R minus
R cos theta.
so r is common, 1 minus cos theta. That is the height. So initial potential energy is 0. So final velocity is v. So half mv square. Final potential energy is mg into h. H means what, guys? H means what? Everybody. H means r into 1 minus cos theta, which is equals to initial kinetic energy. What is the initial velocity? U. So that half mu square. So that is what initial kinetic energy. Half mu square. Clear, everybody? All of you understand, Amma? Yes, please. From A to B. So this point is A. From this point is A point, and this point is B point. So from A to B, if you notice A, so what will happen? Initial potential energy and final potential energy. So everything is over. Now, if you notice it, all the cases, m is common. So m will get cancelled. So you can find it. Everybody see that. So velocity is equals to what will happen? This will become v square by 2 is equals to, you can make it this one this side. So you can write as a u square by 2, this, it will come this side. So what will become? All of you. I'll take it as a LCM. So you can solve this one. So what will happen, guys? Everybody see that? All of you? So v square, what will happen this one? So v square plus, I will write it as a 2 is the LCM. So 2gr 1 minus cos theta, which is equals to u square. Clear, everybody? All of you? Please respond.
Yes.
Yes. So this is what, if you want to find a v, we can find what is the minimum velocity so that a body is falling at this point. What is the velocity at the B point? If you want to find it, you can find it. With what velocity body is falling towards the downward direction, means where normal becomes 0. So that is what we can calculate it. For example, if you take now, so at a B point, all of you observe, B point alone, I will check it. Everybody see that? B point alone. So now if you notice it here, okay, so all of you observe, so there is a circular track. So initially body is at here. So body is at here means it is already having a velocity u. So what is the velocity of the body? A point, u. And finally body has been reached to the B point. Observe very carefully. Finally body is reached to the B point. So that from the initial point, it is making an angle theta. So some angle it is making theta decrease. So at this point, n becomes 0. Normal reaction becomes 0. So body is taking into what path, guide? Body is taking into what path? It will take into the projectile motion. So now definitely there is a velocity at here. Am I right, Rudreswar? Clear? What I am saying? All of you understand? So now there is
Yes,
a height. This total height is r, we all knows that, and now body has been reached to this point. So if you want to find this h, so we all got it, h is equals to what? R minus r cos theta. So h is equals to r into 1 minus cos theta. Now if you apply the work energy theorem from A to B, if you apply the work energy theorem, so at first A point you tell me. So A point is just above from the ground. All of you tell me, at A point above from the ground, from A to B it has been reached. A to B. So at this point, you can see what is the velocity? V equals to it is at the B point velocity is V and A point velocity is U. Now, if you notice it, already initial velocity is not 0. So at this point, kinetic energy is equals to half m u square. Am I right or wrong? Everybody clear? Yes, please. So work energy theorem will says that initial kinetic energy plus initial potential energy is equals to final kinetic energy plus final potential energy. So whatever it is, you can make it. Okay. So now if you notice it here, all of you. So as at what velocity body will falls, that is only the question. So what will get initial potential energy, sorry, initial kinetic energy is half m u square plus what is the potential energy at this point, everybody? What is the change in potential energy? Check it, everybody. What is the potential energy reaches to here? We have found it. mg r into 1 minus cos theta, which is equals to final potential energy is, sorry, kinetic energy is mv square. So m will get cancelled. We'll get it. V square is equals to root over, sorry, V is equals to root over u square plus 2gr into 1 minus cos theta. So this is what the velocity at the B point which we will obtain. Okay. So when the body is traveling. Now, at a B point, all of you, body came from A to B now. All of you check it. From A to B, body has been done. Now at a B point, let us check it. What is that? All of you check it, all of you. If you notice it here, body has been reached to the B point now. So this is the B point. So as we know, at this point, something is acting downward direction. What is that called as, everybody? What is that called as? Which is acting downward direction? There is a force which is acting downward direction, which is equals to what? mg, weight of the body. Now, there is a reaction opposite to this one. That is what we used to call as normal. So if mg is acting like this, the force will split into two different directions. One is, what will happen here? Everybody, this will turn into mg cos theta, and opposite one, this will become what? mg sin theta. So now at this point, all of you please tell me, now normal reaction, what will happen? Both are opposite direction. Normal is like this and tangent, the tension is acting like this. So I can write mg cos theta minus n, which is equals to centripetal force which is acting along the same direction. So that is what we used to call as mv square by r. So which is equals to mv square by r. So now from that n is equals to, what will happen? N is equals to mv square by r plus, what will happen, guys? mv square by r plus, you can see that, oh sorry, minus. So it will come this side. So my n will go this side and it will come this side. So what will happen, everyone? mg cos theta minus mv square by r. So now we all got it. Just to replace the v. So n is equals to mg cos theta minus, let me take m and r is common. Okay. And velocity means we already got v square. What is the v square is equals to root over u square plus 2gr into 1 minus cos theta. You just replace this one at this point. So what will happen? Velocity v square means how much, everybody? U square plus 2gr into 1 minus cos theta. That is one. Now try to solve this equation. So what will happen? mg cos theta minus m into u square. Let me write first like this one. M by r, u square plus, this I will multiply it. So I will get 2gr plus into minus minus. So I will get 2gr cos theta. Clear, everyone? Now, mg cos theta minus m into u square, mv square by r. Next, plus into minus, minus m2gr by r. Okay, let me take this is capital R because everywhere R. So here also R, I will take capital R. Okay. So now, last one, minus into minus, it will turn into plus. So m into this one, m into 2 into g into r cos theta divided by r. So if you all notice it here, what will happen? RR will get cancelled, RR will get cancelled. So what is the final answer? All of you check it. So normal reaction, n is equals to, what will happen, everybody? 3 into m. You can make it, everybody. Mg cos theta. Let me write it. Mg cos theta. Mg cos theta. Next, minus mu square by r minus mg, sorry, 2mg, you can take it, plus 2mg cos theta. So 2mg cos theta plus mg cos theta, which is equals how much, guys? Tell me. Mg cos theta plus 2mg cos theta, which is equals to 3mg cos theta. Next, minus 2mg and minus mu square by r. So this is the normal